everyone. First and foremost, I would like to wish all my Muslim students a very happy Hari Raya. Hope you enjoyed it as much as I do. That is why my video is slightly delayed than scheduled. I have to really apologize for that. Anyway, we still need to proceed with our teaching and learning activity. So in this video, I will guide you through the topic of anthropometry. It may sound very Greek to some of you, but don't worry, we will learn about anthropometry in product design and how we can apply human differences into our design. So stay tuned. The word anthropometry originated from the Greek word, which have the meaning of anthropos, meaning man, and metron, meaning measure. So anthropometry is the measurement of man. It is a study where we measure various physical traits of human beings, such as the height, the weight, the size of the palm, the shoulder height, and so on. Why do we need to adopt anthropometry in our design? You're different, I'm different, God made us different. Everybody have a different physical trait. I can see some of the students in my class are very tall, some are very petite, some are slim, and some are cute and chubby. Anthropometry is very important to ensure our design fits the majority of the population of our user. So take this remote for example. Right now it fits my palm very nicely. So imagine if the design of this remote is based on the palm size of a giant. Most probably it would have a size of this book instead. If the remote is this big, it would be very difficult for me to change the channel. I would need to control it with two hands. So if we do not consider the right anthropometry in our design, our product would end up being impractical. In engineering application, the anthropometry data is being used to design the working tool or the equipment, such as this gripper. We have to make sure the size fits our palm nicely. Other than that, the data is also used to measure the workstation, such as the height of the table or the size of the chair. Even job design requires anthropometry data. For example, how far can the hand reach to grab the spare part for the assembly. So probably very related to us right now is how we can use anthropometry data to adopt in our product design. We have to make sure our product fits the size of our customer. So the main goal of applying anthropometry data in our design is to enhance the user experience and efficiency and improve the user comfort as well as improve the safety of the operator. The body size is different among different population. Take Asian people for example. We have smaller build than the European people. So let's say a manufacturer based in Europe wanted to export their product to Asian market. So they have to consider the anthropometry data of the Asian people, not the European people. If we customize our product to fit one very specific user or one specific individual, then it will be very impractical and the cost of the product will be very expensive. So that is why most products which are mass produced have to be designed so that it can fit a wide range of users. Anthropometry data are measured across a standard measure. For example, during standing, you can measure the standing height, the height of the eyes, the shoulder height, waist height, and buttocks height. During sitting, you can attain the sitting height, eye height during sitting, upper arm length, upper and lower leg length, and so on. Here are some other anthropometry data measured. For example, reach of the arm, head measurement, as well as the palm measurement. You can refer to the lecture notes for details. The anthropometry data can be collected by using the anthropometry measuring kit. For example, large body width such as the shoulder length can be measured using the large spreading caliper. Smaller body size such as the head can be measured using the small spreading caliper. Even smaller body points can simply be measured using the sliding caliper. Circumference of body parts can be measured using the measuring tape. Large distances such as the body height, shoulder height, and waist height can be measured using a vertical measuring tool called anthropometer. Modern measuring kits such as the 3D body scanner are able to attain more accurate measurement, whereby critical body points are scanned and digitized into 3D model. Anthropometric surveys are quite expensive to be carried out since large number of measurements have to be made on sizable samples of people, which represents the population of our study. So you have to pay quite a huge sum of money to each respondents for their participation. Malaysian anthropometric data, in specific, can be accessed through compilations from various journal publications. You can find them in academic journals from various authors such as from Prof. Baba Madros of UKM or Prof. Siti Zawiya of UM. Data from Prof. Baba is shown in the lecture slides. US, for example, have very comprehensive registered anthropometry data of their population. Similarly, you can just search for their data online. The principle of the anthropometry data are based on the normal distribution curve as shown. If we collect the body size across a large population, our data will be distributed following a symmetric bell curve. So this curve means that majority of the population have an average build or average size. Less people are within the lower percentile with smaller than average build, and not that many people are within the higher percentile, those who have body sizes larger than the average. So the two main parameters in the normal distribution curve are the mean or the average and the standard deviation. So after this, we will look into the examples how we can apply calculation of the anthropometry data based on the normal distribution curve. The mean is the total of all individual measurement divided with number of measurement taken. It is simply the average of our data lah. It measured the central tendency of the data from our population. If we look at this data of human height, the location of the mean showed that women have lower height of about 65 inches compared to the height of men with average of about 73 inches. Standard deviation, on the other hand, is like the range of your data. It measures the dispersion of the normal distribution curve. If the standard deviation is small, then we can say that most of our data is very close to the mean value. If the standard deviation is large, then it shows that your data is scattered further to the mean value. One of the very useful measures for our normal distribution curve is by using the percentile value. The percentile value shows your position compared to the overall population. Okay, the 0 percentile will be on the leftmost side of the distribution graph. The 5 percentile is over here. It means that 5% of the whole population would have a body size within this range, which is the lower range of the measurement. So this is the 10th percentile. Most people would fall within the 50 percentile. So that's why you see the curve peak over here. It means many people have the measurement within the range of 50 percentile or the average of the population. Further to the right is the higher percentile value. So 95 percentile is over here. It means that 95% of the population would have the body size within 0 to 95, within this range. And the rightmost side is the 100% of the whole population. Each of the percentile value correspond to a specific z-score. The z-score is related to the probability data. It's like the location of percentile within the x-axis. You can refer the z-score from the z-score table. The z-score for 5 percentile is negative 1.65. Higher percentile would have higher z-score. 50 percentile would have z-score of 0 because it is located in the middle of the distribution graph. How about 95 percentile? So you remember, the normal distribution graph is a symmetrical curve. So if 5 percentile is negative 1.65, 95 percentile is the 5% on the right region of the graph. It's like a mirror image. So the z-score would be positive value of 1.65. The calculation of percentile are based on this equation where P is the data that we want to measure, M is the mean value of our population, Z is the z-score which correspond to the percentile value that you choose, and SD is the standard deviation of the data population. In this example, it is given that Ali have the height of 165 cm. So we wanted to measure the percentile of his height compared to the population of the US adult male. So given the mean of the US population of an adult male to be 175.6 centimeter and its standard deviation is 6.7 cm. So we just use the previous formula for our calculation, where the P is Ali's height of 165 cm, M is the mean of the US population, which is 175.6 cm, Z is unknown, and the standard deviation of the US population is 6.7 cm. So if we solve this equation, we will get Z to be negative 1.58. Now, let's refer this value to the Z table. We will see that negative 1.58 corresponds to the 6th percentile of the data. So if we illustrate Ali's position on the normal distribution curve, he would be somewhere here. This means that about 6% of the US male population are shorter than Ali. It also means that Ali is within the shorter range of the US population. Okay, in this example, Jenny is designing a new golf cart. So she wanted to know what is the suitable height of a golf cart which could fit most of Malaysian population. In this case, the user would be sitting in the golf cart. So the suitable anthropometry measurement that can be considered is the sitting height. If she refer her calculation to Malaysian women, then most probably some men who are tall cannot fit in her golf cart. So she need to consider larger range of sitting height. In this case, the 95th percentile of the anthropometry measurement of Malaysian male would be a good reference. But the Z-score of 95 percentile is not available in the Z table. So how? Remember, our normal distribution table is symmetric. If the 5th percentile have a Z-score of negative 1.65, the 50th percentile or the mid-region of the normal distribution curve would have a Z-score of 0. So 95 percentile is like the 5th percentile on the right range of the curve. So therefore, the Z-score for the 95 percentile is 1.65. If we apply all this value into our equation, we use the sitting height of average Malaysian male of 85.5 cm, the Z-score of 95 percentile of 1.65, and the standard deviation of Malaysian male to be 5.9. So therefore, the recommended height for the golf cart should be more than 95.23 cm. I hope you get the idea on how you can use the anthropometry data and its percentile value to determine the suitable dimension for your design. So why don't you try out this exercise? I'll count this as your weekly attendance. Okay, all the best!